Just introduce myself. I'm Prajwal. I'm a software developer in Tesco. I joined Tesco at a very interesting time. Tesco was on a mission to give a wonderful experience for the customers, to bring in that omni-channel experience for the customer. That was a great vision that Tesco started almost 5 to 6 years back. And in order to achieve that vision, they wanted a very strong technological foundation. I think that's where they set up a very good technological team. They got in right folks from all over the industry just to ensure that we have a right team to get started with. So looking back, I think we have come to a point right now. I wouldn't say that we have achieved everything that we wanted to from a technological retail platform perspective, but the challenge has been pretty amazing, and we have gone through a number of iterations before we got to a point wherein we are able to cater to the orders across all the channels within Tesco in our current technology retail platform that we have built in-house for Tesco, supporting all the orders as we are speaking now, right across 2,000 plus stores within Tesco, and handling all the online orders at the scale. And we had to do this during critical times like COVID, and the only channel for us to get orders were through online while all the stores were shut, but still operational to ensure that we were delivering orders to the customer. Now, today I've come here with a very interesting problem. I'm sure most of you guys who are working in the current next-gen platforms, wherein you are probably using microservice architecture or you're using a service-based architecture where your entire domain is divided into multiple subdomains, and different subdomains are handling different parts of your domain, right? Different parts of your entire business. Now, the interesting thing to note here is previously, we had a single domain or probably a single service which was catering to the entire business needs, there were certain advantages and disadvantages. Let's not get into that, but just to give a little bit of a context on the problem statement here. So imagine you had a big domain where you probably had a single database and all of the different domain elements were within a single database. Now, achieving transactionality in that space is a much more easier one because your database was pretty much taking care of a lot of things for you, right? It was doing a lot of hard work from an application perspective, and achieving transactionality through databases was pretty straightforward, and it was a day one requirement from any database that you would choose. But the moment we went into a microservice architecture, right, you are looking at a slightly different architecture wherein different subdomains will have their own databases, right? So just to put certain things in context here, so from a retail business perspective, there are a lot of domains. I've just put few domains out here. One of them is a customer order domain, which basically takes care of all the order management for the customer. Then you have your payment domain. Then you have your fulfillment domain. Then you have your invoicing and pricings and promotion related domain. So all of these domains put together, they work together to give a unified customer experience for a customer, right? Now, from a customer perspective, he wouldn't know about all of this. So he's only worried about getting his order placed and getting it delivered from Tesco, right? Now, I've just taken one use case here, even though it does not represent the actual system. I've just taken a use case just to align everyone here on the problem statement that we're talking about here, right? So imagine you're a customer, you have built your basket, you have selected a delivery slot for yourself. A slot is basically your preferred slot when you expect your order to be delivered. Now, you are at your order checkout, or we call it as an order confirmation page, right? Now, from a Tesco perspective, before I can confirm your order, I have to take care of a lot of things from a business and as well as an operational perspective, right? So, for instance, I have to ensure that before I can confirm and give you a promise, I have to ensure that I'm reserving that slot for you, right? If you're asking for a tomorrow slot, 11 o'clock to 12 o'clock, I have to ensure that I've taken care of the transportation, I've taken care of, the logistics around it. I have to ensure that I've reserved the stocks for the order that you're placing. I have to ensure that I'm taking the payment from you, right? So that I have a guarantee that the customer has paid the order so that I can start the logistics for it. And from an order domain, as I said, I also have to update the state of my order resource, right? So my order is going through multiple states, right? From the point of view, starting the order journey till it has reached the order confirmation part. And definitely we also need to notify about it. So we are still event driven in many places. For instance, in this case, once an order gets confirmed, that's when the fulfillment process actually starts. So how would a fulfillment process know that an order has been taken from a particular customer. So we have some eventing system in place wherein we notify, and different fulfillment systems like transportation, pickers, and all of them listen to this event and they start the operations on the back end. Now, interesting thing to note here is on a single order confirmation, right? Because we have multiple domains taking care of different aspects of your order journey, we need to get a confirmation across all the domains, right? From the reservations till your payment, till your database update, including yourself, and also your events that you need to publish. Now, the same thing would hold good. I know that we are talking about an API here. On a contrary, if you are event driven, there could be some other use cases in your system wherein you're still talking to multiple dependent services. You have your database update and you have your eventing to publish. In general, whether it's event driven or if it's an API driven, both problem statements are similar in their own respective places. Now, just to formalize things, I just took an example there just to formalize things so that it's more generic enough. So in general, whether it's an eventing or an API, you're looking at talking to multiple dependent API services. Then you have some database update to be done within your domain. And then you also have something to publish for some dependent services to consume from. So from a transaction, when I say distributed transaction, right? So a transaction is basically spreading across dependent API services, your database, and your eventing bus. So now how do we ensure that all of these steps are always complete or not? Now that's a problem statement that we're dealing with here. So in this session, I want to present some options that we evaluated and some practical experience as to where we ended up and what's the option that we're choosing and how there are constraints with all options. I'll still speak about those constraints. And at the end, I'm sure you guys will have some options to go back with and see whether some option fits, or you can probably change few things there to make it work for your use case. So unfortunately, I wish I could say that there is one option that works for all. It doesn't. There are a lot of challenges, and there are some domain-centric elements that influence your design choice as well. Now, I know that this talk is about DTM, but the fact is that if there is a way for you to avoid the distributed transactions in the first place, I think we should do that, because it's not a pretty problem to have. If you are in your domain or any e-commerce domain, now imagine a case wherein you have reserved your fulfillment, you have taken the payment, but just because your own database is not working, now the customer would not be able to check out the order. Now you need a way to recover from there. It's not a pretty problem for you to have, specifically when you're dealing with a big billion day sale or a Black Friday or a Christmas slot opening. Now, how do we ensure that we can remove it? Definitely, we need to have some product conversations. At least in our case, it was not possible. At least, let's say if there is an open chance wherein you can do those reservations after checkout, that will be much easier, right? You're reducing one less overhead in your customer checkout journey. I think if that's possible, well and good. But at least in our case, it was not possible. Now, let's say if you cannot completely avoid it, but let's say we could definitely reduce the number of steps you have in your transaction boundary within a particular journey, right? Now, either we can reduce it, or we can actually talk to the products and understand if we can do it asynchronously after the event is generated. So the whole idea is try to avoid it. If you cannot, at least try to reduce it. If you cannot reduce it, try to order them. I think the order of your business interactions or the dependent service interactions also plays a very important role. I think we'll see that in the next slides. So just to simplify the problem statement a little bit, I've just separated them into two concerns. So the one is, let's try to understand how to solve the problem from an API perspective. So how do we deal with ensuring transactionality with your dependent API services, which is most likely the case. We are always interacting with dependent services either through HTTP, gRPC, or any other protocols. Now, how do we deal with those cases? And then we'll figure out how do we deal with design choices for ensuring transactionality with your database and your eventing bus, right? We'll just separate them out into two buckets because there are different design choices for each one of them. Okay, so just focusing on the APIs bit now. So imagine your domain is dependent on, let's say, 3 dependent API services, and you need to ensure that all of them are either complete from API interactions or none of them are done. Now, there are certain factors that influence your design choices here. I think the first most important factor is the nature of your dependent API services. Is there a state change when you are interacting with the dependent service, right? Now, there are certain interactions where there need not be any state changes, right? It could just be validating certain things, right? Before I confirm an order, if I had an option to just say, just validate that the payment card details are fine, right? That is still a good place for you to be in, because you're not changing the state of your dependent services. Only when there are cases where you're changing the state, that's when it becomes a bit trickier for you to manage. Then the maturity level, right? So imagine the dependent API service that you're talking to, if it's idempotent in nature, that's a good place for you to be in, right? The maturity of the API is so high that even if you retry certain operations, that's not going to affect your domain from a business perspective. That's very crucial, because there will be errors in your online journeys, there will be timeouts, there will be unforeseen errors, and during such cases you need to have a recovery mechanism. That's why the API maturity of all your dependent services also play a big role here. Now, again, the categories of errors are also very important. There are certain errors which are recoverable errors. So when I say recoverable errors, they could be timeouts, they could be some 5xx, or they could be some intermittent errors. But there are certain non-transient errors. Imagine you are trying to do a reservations for a particular slot, 11 to 12 tomorrow, right? Now, there will be competition for that slot, because every slot has a minimum number of orders, let's say 100. Now, if 200 customers are competing for it, then 100 customers will not be able to check out their orders, right? Now, those are all non-transient errors. You can never confirm that order. No matter how many times you retry, will always be stuck in that place. So this definitely influences your design, whether you're dealing with an idempotent service, are you dealing with a transient error or a non-transient error, and are you dealing with a state change in the dependent services, right? Now, coming back to this, this was one of the first, or let's say the most common one that you find on the internet around this. It's a very interesting one, a simpler one, but also comes with a lot of limitations. So the idea is very simple. So instead of just going ahead and just doing the transaction, just check if everything is fine before executing the transaction. That's what it means. So first phase is about you are trying to check whether everything is right. So from an example, you are trying to check with fulfillment, you're trying to check with payment. Before I execute this transaction, is everything okay? It's more like a pre-validation step. And then you have your post-execution step, which is, no, okay, once everyone comes back and says, imagine fulfillment says, yes, the slots are still available. Payment says, yes, the payment ID is valid, and there is enough balance in the account. And the invoice says the pricing has been checked. The whatever price we have promised is the price that we are going to give for the customer. Now, from an executor perspective, which is the order domain here, it could go ahead and execute or commit the transaction. I think going by the 2PC terminologies, it's basically a proposal phase and a commit phase, or there are other equal terminologies that people use on the internet. So this is basically pre-validation step and the execution phase. Now, if fulfillment comes back and says, no, there are not enough slots available, then the order domain can decide, okay, out of 3, one of them came back saying that it's not available for us to do the transaction, so they can abort the whole transaction. That's a very fairly high level view of it. Now, what are the big challenges here? When things are working fine, everything looks good. The challenges comes in only when there are errors. Imagine you have sent out a prepare to commit request to all of the dependent services, and then you as an order domain, let's say you, for unforeseen reasons, let's say there is a restart of your service, or there's a timeout with some of your dependent services, which means that when you recover, you don't know where you had stopped. Did you stop in the first phase or the second phase? So that implicitly means that you need to have some kind of a state management for your transactions, right? It's demanding for you to have a centralized state manager or a centralized store or a cache wherein you can store this request phases, whether you're in the first phase or the second phase, so that you can use that to recover from those errors. Now, interestingly, for our domain, we didn't choose this approach. I'll give you the reasons for it. So for our domain, there were few things that were working out very nicely for us. The first thing is, if you look at the pre-checks, the first part of your prepare phase. So what we realized is, by the time a customer has reached the confirmation page, a lot of these validations are already done. In your order summary page, before going from an order summary page to the payment page, these preconditions are actually validated every single time. So that was a good place for us to be in, which means implicitly we were already doing the first prepare phase, which means we didn't have to waste the latencies specifically for doing it once more. That's a good thing. Then the second thing was, anyways, we have to do a state management here, which is I need to figure out, some state has to be managed for you to recover so that if something has failed, I can continue from there, right? So that gave us a little bit of motivation to bring in an implicit transactional manager within the same service, right? It was not an explicit transaction manager, just to highlight what it is. It was implicit within the code. Now, as I said, the pre-step was not the problem because we have already done that by the time we have reached the confirmation page. Now we are looking at how do we ensure that we recover from failures. So it's a very simple one, like any other transaction manager design you would have seen. So imagine I'm going through so I've skipped the first part. So I'm only looking at the commit phase now. So I'm going through all of the steps, and let's take an example here. Imagine reservations for fulfillment is done. I'm trying to take the payment for an order, and let's say the payment fails for multiple reasons, authorization failure errors, or it could be lack of funds in his account, or it could be a payment failure from a payment gateway as well. Now, this is it's not a transient error. So it's a classic case of how do we compensate for these actions, right? That's a first option that we have. The second one is assuming that a customer, today we don't do that, just to let you know, a customer is allowed to enter new payment details. So he actually ends up adding new payment details in the session. Now the whole operation is retried from a consumer perspective. Now once the whole operation is retried, we have already done the reservations for the customer here, right? Now assuming that the payment succeeds, then everything is fine, which means that we have somehow recovered from the error. Let's take a case wherein the payment fails now, even after entering a new payment details. Now, let's take a simple case here. It's not an authorization failure or a fund failure. No, this account has enough funds. Everything is fine for you to take the payment. It was just a timeout error. Now, this is where the transaction manager kicks in. The approach that we took is we don't record every single step as part of our transaction state update. We only take care of just the high level failure points. I'm so sorry, I got distracted from that. So we just take care of only the failure points, and we just store it only during the failure points. Now that was an optimization that we brought in. So this was working fine for us in production, to be honest. So what it meant was we know when we failed out of those steps, and we know how to recover from that failure point onwards. Now, coming back to this, I think then we had a little bit of conversation within the team. We pushed team to say that, I think we need much better solution than this, because it looked a bit raw in nature, and there were a lot of failure points that we had introduced because of the additional cache that we introduced for transaction manager. So we worked with the dependent services. We pushed them to be more idempotent in nature. I think that changed the game for us, because the things that we were recording in the transaction manager is no longer needed, because we know that the idempotent service will take care of itself. We can just retry it n number of times, and it doesn't matter how many times you retry, you still get the same experience, or at least the same behavior from the API. Now, coming back to the problem statement that we had, I just have 5 more minutes left. So we just figured out some ways to handle the dependent APIs part. Now let's look at how do we handle the data store and the eventing bus part. This is a very interesting one, quite simple one, to be honest. So it's a standard pattern wherein let's avoid the problem in the first place. Let's not store the data and events together. Let's not store the data in one store and events in the separate store. We'll store them together in a database. We're relying on the database here for atomicity, which works very nice. Only when your event cardinality is very less, right? If your cardinality of your events are more, which means you're storing more in your database, and you need to take care of, clearing those from your databases as well as we go on. A slightly different approach. I just want to spend a little bit more time on this one. That's why I had to skim through it a little bit. So the idea with this is you are relying on your state of the resource. In this example, your order is your domain. Now, if your order is already in your confirmed state, imagine you're a customer and I've stored the database, but I failed to emit an event, which is again a problem because fulfillment wouldn't start. Now, if my order is already in the confirmed state, now if the same operation is retried because of some partial failures where I was unable to publish the event to the database, to the eventing bus, in this case, I could just do a republish because I know that for this action, my target state is already achieved. I think the key thing to note here is for a particular action, what is your domain state, right? I think that's more or less fixed. If you look at any API operations, if there is an API operation that you're doing on a domain resource, there's always a target state associated to it. Now, if that operation is complete, you know for sure that the API previously you were able to commit in your database. Now, in this case, what we have chosen is we just republish the failed event. Now, this would result in duplicates. If you try 10 times, you would have 10 events in your eventing bus, but it's still okay because we're still working with an at least one semantics. We want to ensure that one event, one confirmed event is at least pushed to your event bus so that the fulfillment can start. And all our event consumers are idempotent in nature. They know how to handle duplicate events in the system. So this works very nice. If you just rely on your domain data, your own domain state and your domain action to determine whether you want to publish the event or not. Now, this is another standard pattern that we see on the internet, which is the only downside of this is I think most people would be knowing about the compensatory actions is you need to have a compensatory action for every single actions in your distributed transactions, which is challenging sometimes, but at the same time, there is no guarantee that you will be able to execute the compensatory actions exactly to ensure that your domain is in the consistent state. We have used this very well in the eventing systems because it is asynchronous in nature. There's no one waiting for your response. You can eventually get into a consistent state, right? You can eventually reach a domain consistent state from a retail business perspective. Yeah, that's pretty much I had. I know that there were a lot of options that we discussed, but to put things in context, in the last minute. So having idempotent services helps, that's your first priority. You can just reduce a lot of burden of state management if you have idempotency implemented across all your dependent API services. And the second thing is figure out if there is a way to avoid transactionality with respect to database and events. If there is a way, well and good. It could be simple outbox pattern. If not, rely on the state of your domain resource to decide whether I have to reach an eventual transactional end boundary, which is to publish an event. Thank you so much for your time. I hope you will have some insights on the different factors to look at, and these slides will be available online if you want to relook at it and see if there's a way to use something out of it. Thank you so much for your time.